All right, guys. So, what I wanted to talk about here is how we can calculate our limiting reactant. Okay? So, in a chemical reaction, like I said, we have multiple things, and we oftentimes can't quite perfectly measure our mole to mole ratios. Okay, so instead we just identify what is going to be limiting the reactant and stopping the reaction from occurring. Okay, so once it gets fully used up, we need to identify, or we're going to identify what reactant gets fully used up and stops the reaction from going any further. Okay, so what I'm going to do is we're going to actually look at some example problems here. Okay, so in class while we are filtering, we're going to be working on these problems. All right, but let's look at this first question. It says if we place 11.6 grams of AgNO3, silver nitrate, with 15.6 grams of copper, how many grams of Ag are made? Okay, so what this question is asking us is saying, okay, if I had 11.6 grams of silver nitrate and 15.6 grams of copper, how many grams of silver are going to be made because one of these two are going to stop us from making any more? So what we can do is just a couple of stoichiometry calculations, okay? So what we can do is we can say, well, 11.6 grams of AgNO3, we can calculate how much copper is going to react with that amount of silver nitrate, okay? But of course, we can't go directly grams to grams. We have to change and do a mole to mole ratio. So for us to do a mole to mole ratio, we have to get our units into moles, right? So we look here, oh, well, my molar mass of AgNO3 is 169.9 grams of AgNO3 to 1 mole of AgNO3. Okay, then our second conversion here is going to be 2 moles of AgNO3 reacts with 1 mole of copper. And then we can go over here and calculate our moles of copper. 1 mole of copper is 63.5 grams. 63.5, there we go, grams of copper. Okay, so we can do this calculation then and say, well, 11.6 divided by 169.9 divided by 2 times 63.5, this 11.6 grams of silver nitrate is going to react with 2.17 grams of copper, okay? So remember, these stoichiometric calculations, really, it's kind of a sentence, okay? What it's saying here is that 11.6 grams of silver nitrate will react with 2.17 grams of copper, okay? That's what this calculation is telling me. So I am going to have copper left over, okay? How many grams are going to be left? Well, 15.6 minus 2.17 that get reacted is going to be 13.43 grams of copper left over, okay? So we just answered that question, what reaction or reactant is left over and how many grams are left. Now let's go calculate, hey, how many grams of silver are actually being made? Well, again, we need to start with our 11.6 grams of AgNO3. We're going to do a conversion because we can't go directly from grams to grams, but we can say 1 mole of AgNO3 is 169.9 grams of AgNO3. We're going to do another conversion here now. We're changing our chemical substance, so now we can do a mole to mole conversion. We can say 2 moles of AgNO3 is going to produce 2 moles of silver in this reaction. And then we can do one more calculation and say, well, 1 mole of Ag is 107.9 grams of Ag. All right, and that's going to tell us how many grams of silver are going to be made. 11.6 divided by 169.9 times 107.9, right? 2 divided by 2, I'm ignoring it. So we're going to get 7.37 grams of silver from this reaction, okay? So whenever we do these limiting reactant equations, we always start with one of our reactants, however much we have, and identify, hey, how much is it going to react with the other reactant? Is that more or less? If it's less, then we can just subtract. If it's more, then we need to go to the other reactant and say, hey, how much is that going to react with my first reactant? Then we can subtract, and then we can identify how much of each compound is being produced. Okay? These stoichiometric calculations are really a sentence. This one is saying 11.6 grams of silver nitrate is going to react with 2.17 grams of copper. But the 11.6 grams of silver nitrate also is going to produce 7.37 grams of silver, okay? And then our calculation here is saying, well, of my 15.6 grams of copper that we put in, 13.43 grams of copper are going to be left over, okay? So all of these calculations, right, have a meaning, okay? So what we can do during class today while we are filtering is work through these problems with our partners, okay?